This is SpaceTime Series 29, Episode 91, for broadcast on the 31st of July 2026. Coming up on SpaceTime, the near-Earth asteroid that turned out to be a comet, NASA's Psyche spacecraft's gravity-assist flyby of Mars, and China's about to double the size of its space station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have confirmed that the near-Earth asteroid 1998 SH2 is actually a comet, further blurring the lines between these two different types of celestial bodies. The problem was, the object originally looked like a typical asteroid in most telescope images, showing none of the usual comet-like characteristics, such as degassing, a fuzzy coma nucleus, and cometary tails. But the unusual thing was, this asteroid was on a comet-like orbit. The new findings, reported in the journal Nature Astronomy, are based on fresh, more detailed observations. The puzzle began back on August 28, 2025, when 1998 SH2 passed within 3 million kilometres of the Earth during its 4.5-year orbit around the Sun. Astronomers took the opportunity to observe the asteroid with NASA's Deep Space Network planetary radar system. They had calculated its position using data from previous orbits and factored in the effects that the gravity of the Sun and planets would have had on its path. But when the asteroid didn't show up where they expected, they realised that something unanticipated must have been influencing its motion through space. By using optical astrometry to precisely measure the object's position in the sky, they were finally able to identify the cause. The study's lead author, David Fenocchia from NASA's Jet Propulsion Laboratory in Pasadena, California, says that after measuring the non-gravitational perturbations affecting the motion of 1998 SH2, his team recognized that they weren't compatible with the object being an asteroid and began to suspect that it may well be an active comet instead. Although 1998 SH2's orbit around the Sun has been well tracked from 1998 to 2016, the object had completed 2 solar orbits since then without any additional observations. Analysing all the observations collected since the object's discovery back in 1998, the authors determined the perturbations to 1998 SH2's motion and hypothesised that the object must be generating a small amount of its own thrust, possibly by venting gases into space. And that was what was causing it to deviate from its projected path. Now, this venting results from the Sun heating ices mixed with rocky material, turning the ice into a gas. With regular comets, this activity forms the trademark bright tail and coma. That's the gas and dust surrounding the comet's nucleus. But when an object produces its gas and dust in much smaller quantities, its tail and coma may not be detectable by most observatories. So, the August 2025 close approach to Earth provided the perfect opportunity for Fenocchia and colleagues to gather observational evidence for any possible visible cometary activity. They used the Canada-France-Hawaii telescope on Mauna Kea, as well as the European Southern Observatory's Danish telescope at La Silla and its VLT or Very Large Telescope at Parnell, both in Chile, to study this object in more detail, in the process revealing a weak but clear cometary tail. As a result, 1998 SH2 has now been given an additional cometary designation, P1998 SH2. The findings also shed light on another, even more unusual class of objects known as dark comets. Like P1998 SH2, dark comets exhibit significant irregularities or perturbations in their trajectories. But they lack other visible evidence of comet-like activity. There's no coma, no tail, and no visible outgassing. These distinct objects fall into 2 distinct populations. Larger ones with orbits similar to those of Jupiter family comets, these are short-period comets with highly elliptical or eccentric orbits, and smaller comets that orbit closer into the Sun. Since the 2016 discovery of the first dark comet, about a dozen more have been identified. The authors suggest that many of the larger dark comets, which have orbits like P1998 SH2's, could turn out to be regular comets. That's if astronomers can get the opportunity to observe them with more powerful telescopes, ones capable of imaging incredibly faint objects. Fenocchia says the work shows the importance of continuously tracking near-Earth objects. Detecting these perturbations would be an important diagnostic tool for planetary defence. that will help astronomers understand which objects may be comets rather than asteroids, how their orbits evolve, and how that could influence their chances of impacting the Earth. This is Space Time. Still to come, NASA's Psyche spacecraft undertakes a successful gravity-assist flyby of the red planet Mars, and as NASA prepares to wind down and deorbit the International Space Station, China announces plans to double the size of its own space station. All that and more still to come on Space Time. This episode of Space Time is brought to you by NordVPN, SpaceTime's official VPN service. Let's face it, these days your online privacy is more important than ever. Whether you're streaming science documentaries, reading the latest research, or exploring deep space images, you don't want your data to be tracked or your location exposed. With NordVPN, one click is all it takes to secure your internet connection. It encrypts your data, hides your IP address, and keeps your activity safe from prying eyes, whether you're at home, work, or connected to a public Wi-Fi. And here's where it gets really good. As a SpaceTime listener, we have an exclusive offer for you. 74% off a NordVPN plan plus 4 extra months for free. That's right, a huge 74% discount plus 4 bonus months just for being a SpaceTime listener. All you need to do is head over to nordvpn.com/StuartGary. That's nordvpn.com/StuartGary. Not only does NordVPN protect your data, but it gives you access to content from right around the world. If you want to watch a science series that's only available in another country, no problem. Just switch your virtual location and unlock it instantly. And of course, the whole thing is risk-free with a 30-day money-back guarantee. So you've got nothing to lose and your online freedom to gain. So protect your digital life, support SpaceTime, and grab our exclusive offer now at nordvpn.com/StuartGary. That's nordvpn.com/StuartGary. NASA's Psyche spacecraft has undertaken a successful gravity-assist flyby of the red planet Mars, a maneuver which will help slingshot the probe to its ultimate target, the strange metallic asteroid 16 Psyche. The 226-kilometre-wide metal-rich asteroid orbits the Sun in the main asteroid belt between Mars and Jupiter. It contains about 1% of the entire mass of the main asteroid belt and is primarily composed of iron, nickel and precious metals, giving it a hypothetical mining valuation exceeding $10 quintillion. Psyche was originally chosen for the mission because it was thought to be the exposed metallic core of a larger differentiated planetary body, which had its mantle and crust stripped away during some sort of ancient impact event. And that made Psyche a prime target for astronomers wanting to study the internal structures of planets. However, as they began getting more and more data on the asteroid, they received mass and density observations that were inconsistent with Psyche being a remnant planetary core. That led to a new hypothesis, suggesting that Psyche had been disrupted and then gravitationally reaccreted into a mix of metal and silicates. That would make it a potential parent buddy for the mesosideриtes class of stony iron meteorites. Another hypothesis suggests that Psyche may be a differentiated object like Ceres and Vesta, but one that experienced a type of iron volcanism called ferrovolcanism while still cooling. Now, if correct, this model predicts that metal would be highly enriched only in those regions containing relic volcanic centres, a view supported by recent radar observations. Meanwhile, by this time the Psyche spacecraft had already launched on its mission. It aced its close encounter with Mars, using the planet's gravity to gain speed and slightly tilting its trajectory. The flyby also gave mission managers an opportunity to prep for the science they'll be conducting when they finally reach the metal-rich asteroid Psyche in 2029. They tested the spacecraft's science instruments, confirming all were operating nominally, providing data that matched what NASA already knew about Mars, and also providing a few new insights about the red planet along the way. Psyche's principal investigator, Lindy Elkins-Tanton from the University of California, Berkeley, says the spacecraft's imager, magnetometer, and gamma-ray and neutron spectrometer teams all worked overtime to make full use of the planetary encounter, and all instruments delivered great results. The gamma-ray and neutron spectrometer, which helps scientists determine the chemical elements that make up the asteroid's surface material, got a real workout during the flyby. As high-energy cosmic rays bombarded Mars, elements on the red planet's surface absorb energy, emitting neutrons and gamma rays of varying energy levels. By measuring these emissions, scientists can match them to the properties of known elements in order to determine what the body's made of. While the Mars flyby altitude of 4,609 kilometers was too far away to measure gamma rays, neutrons escaping the planet's surface and atmosphere could be detected. The mission's magnetometer is designed to measure Psyche's magnetic field, and it was designed to test the idea that it could be the metallic core of a planetesimal, the building block of a rocky planet. While this instrument's been constantly measuring the solar wind's magnetic field throughout its cruise phase, including when occasional coronal mass ejections washed over the spacecraft, Mars was the first magnetic field signature of a celestial body that the magnetometer was able to measure. As the spacecraft passed close to the red planet, the magnetometer saw an increased uptick in magnetic field corresponding to the bow shock region, where the solar wind slams into the planet's magnetic field. Meanwhile, the spacecraft's multispectral imager, a pair of identical cameras designed to photograph the surface of the asteroid in different wavelengths, delivered some stunning views of Mars during the flyby. Because of the high phase angle at which the spacecraft approached the red planet, Mars initially appeared as nothing more than a thin, bright crescent with sunlight scattering through its atmosphere. During close approach, the imager team captured detailed views of the Martian surface, including wind-blown craters, the South Polar Ice Cap, the large double-ringed Huygens crater, and the two Martian moons Phobos and Deimos. Psyche project manager Bob Mays from NASA's Jet Propulsion Laboratory in Pasadena, California, says the Psyche spacecraft remains in great shape and is now headed directly towards its ultimate target. He says the probe's on schedule to resume sustained thrusting using its solar electric propulsion system in a couple of months' time. This report from NASA TV.
For a fleeting moment on May 15, 2026, NASA's Psyche spacecraft drew close enough to Mars to see its craters, calibrate its instruments, and then it kept going. Coming within 2,864 miles of the red planet's surface, the Psyche mission got a critical gravity assist on its way toward the metal-rich asteroid, Psyche. Analyzing radio signals between the spacecraft and NASA's Deep Space Network, Psyche's flight team confirmed Mars gave the spacecraft a 1,000-mile-per-hour boost and shifted its orbital plane relative to the Sun by more than 3 degrees, setting it almost perfectly on its planned trajectory to arrive at asteroid Psyche in the summer of 2029. During the flyby, Psyche's imagers, magnetometer, and gamma ray and neutron spectrometer instruments were powered up and collected data to take advantage of the valuable calibration opportunity the close approach offered, comparing its measurements to surface and atmospheric data from several other Mars missions. Psyche's spectrometer measured neutrons coming from the red planet's surface during close approach, something it will do at asteroid Psyche to better understand what it's made of. The magnetometer detected Mars' magnetic field interacting with the Sun's plasma as the spacecraft passed through the planet's bow shock, a trial run for when the instrument will measure the asteroid's magnetism. And Psyche's multispectral imager was especially active.
An event like this takes a ton of planning. We like to use a system called Cosmographia to simulate everything in advance. How close do we need those images to be as we pass really close to Mars in order to see enough of an overlap that we can make a huge mosaic out of it. It gives us a beautiful opportunity to see the big picture and to really put it all together.
As a bonus, Psyche's multispectral imager captured Mars from a rare perspective.
Coming in at such a high phase crescent, only 4% of Mars was illuminated, and with that we could see the atmosphere around it glowing.
So you could see clouds on Mars. It was really quiet as the three of us just kind of sat back there looking at it. My favorite image is the one that looks like an eye, and I love how it starts with Mars as a really tiny little crescent, and then every day it gets slightly bigger and slightly bigger until we have 14 images stacked up. So it gives a nice perspective on the speed the spacecraft is traveling at.
The detail that we were able to see in some of these terrain, I personally was blown away. The southern polar cap, Huygens crater. I think the wind-streaked terrain was really interesting. It shows active processes happening on Mars.
It was very exciting to be able to finally put the whole thing together and then see Mars getting bigger and then smaller in the field of view again. It feels great to finally have more to share with the world.
With Mars behind Psyche, the spacecraft will soon resume thrusting with its solar electric propulsion system. Next stop, the asteroid belt, onward to Psyche.
And in that report from NASA TV, we heard from Psyche multispectral imager operations team members Nicole Gonzalez and Hannah Zygo, both from Arizona State University. This is Space Time. Still to come, China about to double the size of its space station, and later in the science report, new clues about how the human body's nervous system senses warm and cool temperatures. All that and more still to come on Space Time. As NASA looks at winding down and deorbiting the International Space Station in 2030, Beijing has announced plans to double the size of its Tiangong Space Station. The expansion will see the orbiting outpost transform from its existing 3 modules to 6, in the process changing its layout from a T-shape to a sort of cross or double T. Included in the expansion will be a new 20-ton class multifunctional hub featuring 6 docking ports and an extra vehicle activity hatch for spacewalks, as well as 2 new modules also in the 20-ton class, all of which will combine to allow China to dramatically expand its operations. The changes will also increase the station's mass from 77 tons to somewhere between 180 and 200 tons, and it will allow the station's permanent crew capacity to grow from the current 3 up to at least 6 Taikonauts at a time. The plans also include launching the new Hubble-class Tiangong Space Telescope, which will fly in formation with the space station and occasionally dock with it for maintenance, refueling and repairs, as well as potential upgrades. The new telescope will feature a 2-metre primary mirror, only slightly smaller than the 2.4-metre mirror used on Hubble, and it will use a 2.5 billion pixel camera. Tiangong is scheduled for launch next year and is expected to have at least a 10-year lifespan. The first modules of Tiangong, Mandarin for Heavenly Palace, were launched back in 2021, with crews of 3 Shenzhou Taikonauts serving on station at any given time. China's also developing new cargo ships to resupply the space station, and it's been developing its new 7-man Mengzhu spacecraft, which will ultimately replace the current Russian-based 3-man Shenzhou capsule. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. New research has challenged what scientists understand about how the body's central nervous system senses warm and cool temperatures. Scientists at the University of Queensland have found that most of the skin's temperature-sensitive nerve cells can sense both hot and cold. The findings, reported in the journal Neuron, challenges the widely accepted view that the skin relies on separate nerve cells to detect each type of temperature. A new study based in the Western Australian wheat belt has found alarming levels of pesticide contamination in the food sources of endangered Carnaby's cockatoos near seed spills at grain silos. Over 3 breeding seasons, wild Carnaby's cockatoos were fitted with satellite tracking tags across 5 wheat belt breeding sites in order to identify where and what they were eating. A report in the journal Environmental Toxicology and Pharmacology claims seed samples were then tested for pesticide contamination, and the results showed concentrations well above regulatory limits. Scientists have found evidence of an ancient species of snake that lived almost exclusively underground. A report in the journal Nature claims the species Temitera miriam, a newly identified extinct snake species found in Brazil which lived around 85 to 75 million years ago, was adapted for life underground. That's in contrast to other early snake species that lived above the ground or in water. The authors say the newly discovered fossil includes a well-preserved 3-dimensional skull and body and is the first known articulated snake fossil found in Brazil. X-rays of the remains show its skull was shaped for burrowing, and its brain was quite different from that of other snakes, both extinct and living. And this suggests snake evolution was far more dynamic than previously thought. A new study warns that working from home may not have a significant impact on your carbon footprint. A report in the journal PLOS Climate claims the emissions saved by not commuting are largely all offset by running a home office. The authors found that working more days from home and having a separate home office were both linked to higher overall emissions. And it wouldn't be Friday without a Bigfoot story. And there's been a spate of 8 Bigfoot sightings over a period of just 5 days in the American state of Ohio. The Skeptics' Tim Mendham says the sightings all occurred in the state's northeast, but they appear to have involved very different-looking Sasquatches.
We've seen 8 times in 1 week in Ohio, in a small area of Ohio, and Trumbull County, and this has been seen from people saying, I saw it at a distance of about 120 yards or so. It was at 100 metres. 9-foot-tall brown-head Sasquatch in the middle of the day, broad daylight. It saw it and then it ran off. Another person said, the hiker said they spotted an 8-foot-tall creature with dark brown hair stepping out from behind trees just 40 yards away. And this one actually yelled and made a deep echoing grunt. A terrified ex-veteran, I don't know what actually being an ex-veteran relevance is, but obviously ex-military, described feeling watched and hearing this hellish roar that left him scared. Obviously didn't see a Sasquatch or a Bigfoot. But I mean, a lot of sightings within a short period of time, 5 days, and I assume that these got publicity at the time. So you would suspect that some people were inspired, were pre-prepared or something, to actually see something. That if they saw something strange, they think it's a Bigfoot. The dogs apparently get very upset, shaking with fear. No definitive proof, no photos. They said they found a couple of footprints, but often if you see big footprints, they're not very convincing necessarily. There could be a lot of things. A lot of interpretation goes into the evidence, and I've seen footprints of supposed Australian, the Yowie. And just kidding, really? Yeah, they don't look like foots. Sometimes.
Very strong correlation between an increase in Sasquatch sightings and an increase in bear populations.
Yes, or deer. Maybe there's a Sasquatch there. Maybe there really is. It'd be fascinating to see. I think we'd all like to see something like that. It'd be very exciting. But as for proof of it, a lot of sightings in one short time is exciting, but not necessarily definitive proof. What I always say is that a bit of evidence which rates 2 out of 10, because you don't have any other evidence, it's just anecdotal, is interesting. 8 bits of evidence that rate 2 out of 10 do not give you a 10 out of 10. They give you a lot of 2 out of 10s, right? And in fact, the more 2 out of 10s you get, the less likely something is to be true, because you say, well, you've only got bad evidence. You haven't got good evidence. We've got a lot of bad evidence. We've got a lot of bad evidence.
And these days, everyone's got a phone with a camera in.
Apparently, these people didn't, including the ex-veteran. It's a thing that people say, it's happening all the time. Yeah, but it's happening badly all the time. It's not happening convincingly all the time. And the more non-convincing it is, to me, the less likely it is to be true.
That's the Skeptics' Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.